Hey class, this is Gigi from Kauai Community College. This is a lesson on the antiderivative, in which we are undoing the derivative. We're going backward. Okay, so if we have a function f of x, big F of x, and that function is called the antiderivative of the small function f of x, if the derivative of f is equal to the small function f of x, right? So we're going backward. Now let's think about what that means for a second. There are many antiderivatives for a given function f of x. And all of these could differ by a constant. Okay, so what does that mean? For example, if you have big F of x is, say, sine of x plus pi, okay, then the small f of x is a derivative, which would be, right, the derivative of the big function f is the small function f of x. It would be cosine of x. And we know that the derivative of a constant is 0, right? So it depends on some specific condition given. But if we were to go backward, if we were given cosine of x as the small function and we were asked to find the big function, well, it could be sine of x plus pi, or it could be sine of x plus pi over 2, or it could be cosine of x plus 3 pi over 2, and so on. That is the constant that we are talking about. So when we go backward, right? So when we go backward, if the function small f of x is cosine of x, then the big F, which is the antiderivative of little f, could be sine of x plus some constant c, because the derivative of a constant is 0. So when we go backward, we would say, oh, hey, the derivative of sine of x is cosine of x, derivative of c is 0. So that is what we mean by there are many antiderivatives, because that c right there could be 1, 2, 3, 4, 5, pi over 2, whatever you like. Then the derivative of the big F, which is the small function f, is still going to be cosine of x. Okay, so that's what we are doing here. So if we were given specific information like this problem here, then we may be able to find the constant c that will make these conditions happen. Okay, so for example, if the acceleration a of t is 3t minus 5, then we would say the velocity function is the antiderivative of 3t minus 5, right? So we would, by my notation, it would be big A of t, which is the antiderivative, and that would be, well, let's see, what must I have to have in order to have, let's do the negative 5 first. I must have started out with negative 5t, right? Because the derivative of 5t is 5. Now here, what must I have started out with in order to end up with 3t? Well, if that's linear, then I must have not 3, but 2, because when we went backward, we would take the 2, bring it down and multiply and then subtract 1, so we would have t. But once we bring down the 2, that would have been 6. So what do we need to undo multiplication? Division. Okay, so now we can see that when we bring down the 2, that 2 will cancel with this 2. That leaves us with 3. And then t to the first power. And that is not it yet, because it could be differed by a constant. So we would say v of t in this case would be 3 over 2t squared minus 5t plus c. Now, how are we able to find that c? We are able to find that c given specific condition. If there's no specific condition given, then we will just leave that plus c as our answer for the antiderivative, right? So in this case, we were given that v of 0 is 1. That means when t is 0, the velocity is 1. So I would have 1 equals to 3 over 2 times 0 squared minus 5 times 0 plus c. So in this case, we would say c is 1. Okay, now that we know c is 1, then that specific velocity function for this particular scenario, v of t is going to equal to 3 over 2 t squared minus 5t plus 1. Okay, next we are looking for the displacement function, or we would say the formula for the position. And so we would say that would be the antiderivative, right? So s of t is the antiderivative of v of t. So I'm going to call that big V of t. That's the antiderivative. And so that would equal to, and I really don't need to write that. We will just say that it's going to be the antiderivative of that. Okay? So how do we do that? Well, remember, the 3 over 2 t, well, we would have to add 1, right? Because when we know that when we take the derivative, we are subtracting 1. So when we're going backward, we're going to add 1. But remember, if I was to take this 3 and take the derivative and move it down, that's going to become 9 over 2. So I have to undo that multiplying by 3. So to undo multiplying by 3, I have to divide by 3, which now give me 3 over 6, and 3 over 6 is 1 over 2. So this is 1 over 2 t to the third power. Okay, so now let's check our answer here in this part by taking the derivative. Bring this down, I will have 3 over 2, and then minus 1, I will have t squared. Okay, so that's how that works. Minus, well, I would have had t squared, but if I had t squared, I would have had to multiply the 2 down here when we're taking the derivative. So to undo multiplication, I would have to divide. So then when we go backward and take the derivative here, we would say 2, bring it down, that's going to cancel with that 2, and I will have 5t. Okay, plus 1t, and then plus, I'm going to call that d, just so that it's different than c. It's just a constant. Okay, now how do we find that constant? Using this information here. That information said when t is 0, s of t is 3. So I will have 3 equal to, and when I plug 0 in for t, I'll have 0 minus 0 plus 0 plus d. So d is 3. Okay, so our final answer is s of t is equal to 1/2 t to the third minus 5/2 t squared plus t plus 3. All right, so that is what we mean by antiderivative. So when we just take the antiderivative, our answer would be whatever the antiderivative is as normally, plus a constant c, because when we go backward and take the derivative, the derivative of c is 0. Okay, So, and given specific information like such, then we can find out what that constant is, like this. Okay? Otherwise, your answer will just be the thing plus C.